Hello everyone, we are going to talk about worksheet 11, which is on section 3.6 and 3.7. When we are doing the word problems, please pause the video whenever you need and then read the question completely, and then you can see the video for the solution. So I'm not going to read the question each time. So if you need to read the question, you can do it ahead of time, or you can pause the video. So for number one, part A, finding the relative growth rate, we are going to we're going to set P of t as P of 0 as the initial value e to the power kt, and we are going to find k, then replace back here in order to find the model. So based on the question, we know that P of 0 is 60, and after 20 minutes, it means that 1/3 of an hour. You can do all in terms of minute, but I think when we convert it to hour, that would be smaller numbers and we can work easier, but you can do for minutes. So based on this information from the question, we would have 0 times e to the power 1/3 of k, which is equal to 120. So by dividing both sides by 60, we would get e to the 1/3 k equals 2, and it means that by using the definition of logarithmic functions, in this case ln, because the base is e, we can write it as k over 3 equals ln of 2. So k would be, if we multiply both sides of the previous equation by 3, we would get 3 ln of 2. And if we bring the power to the top, because we had the formula which says whenever you have a, log, or ln, it doesn't matter if it is log or ln because they are from a family of m with any base like b, we can rewrite it as log of m with the power a with base b. Same thing for ln works. So in here, I'm gonna write it as 2 to the power 3, which means k is ln of 8. We're not going to use calculator to find ln of 8 in terms of decimals because we would use that decimal, and if we want to write that here, we would cut it off or round it up. So it will be more error if we want to use it and then curve another time. So k is ln of 8. For part B, it says for the expression or the model, we would replace it back. So P of t would be P of 0 e to the kt as the formula we had. So P of 0 is just 60, e to the power k is ln of 8 times t. And using another formula which says, let me write it in terms of ln this time. E to the power ln of whatever you have, that would be m. We have the same formula with any base. Let's say base b to the power log of whatever you have with the same base. That would be m also. So following these formulas, we can rewrite P of t as 68 to the power t, because e to the power ln of whatever we have following this formula will be m, which is 8 here, to the power t. So part C says We want to find the number of cells after 8 hours. So if we remember from the formula that we had, we would say that dp dt is proportional to the population here. So dp dt is p prime of this one, which is 8, p prime of t, but in here t is 8, equals k and the population after 8 hours. So we know that k is ln of 8 and p of 8 is here. So it will be ln of 8 times p of 8. We had the formula for p in the previous section, which was, okay, so this is D. I forgot to write C. So let's do C here. For C, after 8 hours, we have to find it out and then replace here. So P of 8 is following the model, which was 60 times 8 to the power T, which is 8 here, because it says after 8 hours. So this one will be using calculator, and it will be this number. Now we're going to use this number here for P of 8. And using calculator, we would end up with approximately 2.093 billion cells per hour. You see here, if we wanted to find ln of 8 in terms of decimal, and then we round it up, and then this one is another one, which when we multiply them, we would have another decimal here that we're going to round it up again. So each time that you round up a number, it will be error. So we prefer not to increase the amount of error. Next part is asking when will the population reach 20,000. So it basically says find t when t, or the model p of t, is 20,000. So the question is, what is p of t? We found it out in the previous section that 60 times 8 to the power t is the model, and we're going to find t when it is equal to 20,000. First, we would isolate the part of the equation that has t. So we're going to say 8 to the power t is 20,000 divided by 60, which means 10,000 over 30 if we simplify. Now, the function that gives us the exponent is log or ln, depending on whatever we have. So in here, we would say for finding t, I can use log of this number with base 8. But since using calculator, we cannot find base 8 in a calculator, we have to change the base. So it will be ln of 10,000 over 30 divided by ln of 8. And using calculator, we would end up with 79 hour. Okay, we will do number 2. Okay, let me move it up. Number 2, based on the question, we have y of 0, the initial value, 50 milligrams. So in order to write the model or the formula, we're going to find y of t equals y of 0 e to the power kt as we had for the model. So it will be 50 times e to the power kt, and we're going to use to find k and then put it back to find the model. Based on the question, half-life is 28 hours. 28 days. It means that y of 28 is equal to 25 because half of 50 is 25. Also, using the formula, the general formula, y of 28 will be equal to 50 e to the power 28k. So the left parts are the same. From the right part, we can have an equation, which is 50 e to the power 20k is equal to 25. By dividing both sides, uh, by 50 in order to isolate e to the power 28k, we would get 1 over 2 here. And we would take ln both sides because the base is e, and using the formulas that we talked about, we're going to have ln of 2 to the power negative 1, which is the same as negative ln of 2 here. And the left part will be 28k equals negative ln of 2. So k is negative ln of 2 over 28. We would keep this one here as a quotient, and we are going to replace it back to find the model. Let me write this one here. So y of t will be 50 as the initial value times e to the power k negative ln of 2 over 28 times t. Again, using the formula that says e to the power ln of whatever you have is the same as that number, we can rewrite it as 50 times 2 to the power negative t over 28 as the model or the formula here. So keep this somewhere. I'm going to erase the board, but we need to use this formula. Part B says y of 40 is 50 times 2 to the power negative t over 28, which is negative 40 over 28. So we're going to use calculator, and it will be 18.6 milligrams after 40 days. For part C, now that we have the formula, it would be easier to do that. So part C is about the rate of decay after 40 days. Whenever you see rate, you would think of derivative. So the formula was y of t equals 50 times 2 to the power negative t over 28. And we're going to find the derivative of this one. We know that 50 is the coefficient, and for the exponential function like a to the power u, the derivative will be using chain rule. So you would have a copy of this one times ln of the base times du dx. We're going to use that here, and we would have 50 as the coefficient, a copy of whatever we have, times ln of the base, which is 2 here, times derivative of the power, which is negative 1 over 28 here. Now, the question is asking about the rate after 40 days. So t will be 40 here. Now we have 50 times 2 to the power negative 40 over 28 times ln of 2 times negative 1 over 28. Altogether, after using calculator, you would end up with negative 0.46 milligrams per year. Part D says, how long does it take the sample to decay after mass of to decay to a mass of 20 milligrams? So it is basically telling us that y of t will be 2. But what is y of t? Y of t, we know that using the model, it will be 50 times 2 power negative t over 28. So left sides are the same. We can put the right side the same. So using both of them, we would have 2 equals 50 times 2 power negative t over 28 as an equation. Dividing both sides by 50 in order to isolate the part of equation that has t, we would have 1 over 25 here. And since the unknown is the power, we prefer to use ln here. So ln of 1 over 25 will be ln of 2 power negative 2 over 28. Using the formulas that we talked before, we would have negative t over 28 times ln of 2 for the right side and negative ln of 25 for the left side. And by multiplying 28 both sides, and after that dividing by ln of 2 to isolate t, we would have t approximately 130 days. Next part is about sketching the graph of the mass function. Based on the information that we had from the question and the parts that we obtained, we have t in terms of days and we have y for milligram. So it will be starting 0 to 50, let's say 10, 20, 30, and 40 here. And for this part, we can set 50, 100, and 150. So the initial value was 50, so we'll start here, and after some time it will be 100, about 130 days, it will be 2 milligrams. So approximately the decay will be like this graph here. Number 3. If you are interested in crime series, that this one would be interesting for you. So after reading the question, we conclude that T of 0 is 32.5 degrees Celsius and T of 1 is 30.3 degrees Celsius and T of the surrounding is 20 degrees Celsius. Based on the formula, dt over dt is k times t minus t surrounding. So in here it will be k times t minus 20 as the formula. And we talked about that y is the inside of the parentheses, which is t minus 20 here. So we know that y of 0 is t of 0 minus 20 based on the formula. which is 32.5 minus 20 equals 15, equals 12.5 degrees Celsius. And also, we know that y is the solution of the initial value problem. We know that dt is proportional to the y formula here. And based on the question, y of 0 is 12.5. Using the theorem number 2, as we talked in the lecture, we have y of t equals y sub 0 times e to the power kt as the model, which is 12.5 here times e to the kt, because we found out that y of 0 is 12.5. Also, based on the question, we know that y of 1 will be t of 1 minus 20, which is 30.3 minus 20 equals 10.3 here. So we would use this in the formula. If you find y of 1, you would get 12.5 e to the power 1 multiplied k. And also using the information that we have from the question, y of 0 is 10.3. So left sides are the same. We would set right sides the same. So 12.5 e to the k is equal to 10.3. E to the k will be 10.3 divided by 12.5, and k will be ln of this fraction. Remember not to round up more than once if possible. So k is approximately, not approximately, we would keep it this as is, and then we would put it back to the formula to find t. We know that k is ln of 10.3 over 12.5. Also, we know that the murder occurred when y of t is t minus ts. T in here is 37 based on the question minus the surrounding, which is 20. It means that y of t is 17. Also, using the formula, y of 17 will be, excuse me, y of t, because we need two things similar. Y of t will be 12.5 e to the power kt. So left sides are the same. From the right side, we would have the equation as 17 equals 12.5 e to the kt. We know that k is ln of 10.3 divided by 12.5. So from this one, t will be ln of 17 over 12.5 divided by k, which is ln of 10.3 over 12.5. Now we would use calculator and we would have negative 1.588 hour, which is approximately negative 95 minutes. So the negative here means before the first temperature that we have. So before the first time that we have. So it was 1:30, and then 95 minutes before 1:30 would be 11:11 and 50. The hour is 11, the minute is 55 minutes a.m. Okay, let's move on to the next one. For number 4, we would have y of t equals y of 0 times e to the k t, as we had before. And also, based on the question, we would see that y of 2 is equal to y of 0 times e to the power 2k, which is 400. Also, we know that y of 6 is y of 0 times e to the power 6k, which is 25,600. We can divide these two equations to get rid of y sub 0, which we don't have yet, and using the power rule for same bases, if we divide them, we would subtract them. So it's easier to put the power which is bigger to the top and the one which is smaller to the bottom. If we do so, we're going to divide 25,600 by 400. This will be 64. So the left side is e to the power 4k and the right side is 64. It means that 4k is ln of 64. And to be easier, we can rewrite it as ln of 2 power 6. Or we can use the formula and to write it as 6 times ln of 2. So k will be 6 ln of 2 divided by 4. And using calculator, it will be 1.0397. It means about 104 or 104% per hour. For part B, it says, what was the initial size? Okay, so we know that 400 is equal to y of 0 times e to the 2k based on the question, based on the previous part. So y of 0 here is 400 divided by e to 2k. And from the previous section, previous part, we found k is 1.3, but we don't use that because we are not going to round it up many times. So if you simplify this, you would get 3 ln of 2 over 2. So we can use that here. It will be 400 and e to the power 2 times 3 over 2 ln of 2. So it will be 400 divided by 2 and 2 will be cancelled and e to the power ln of 2 will be 2. So altogether it will be 8. And the answer is 50. So we know that the initial size is 50. We would use it in the next part. Next part is asking about finding the model or expression. Now that we know y of t is y of 0 times e to the power kt, and we know that y of 0 is 50, and we know that k is 3 over 2 ln of 2 times t. So altogether, we will have 50, and we would use the formula, and also we can use the formula to get 2 to the power 1.5 t. So this is the model. Using this model or expression, for the next part, we are going to find the number of cells. So let's move on for part D. Number of cells after 4.5 or 4.5 hour, it means find y of 4.5, which is using the expression 50 times 2 power 3 over 2 or 1.5 times 4.5. Now again, using calculator, it will be 5382 bacteria. Part E says find the rate. Okay, so we know that dy dt is proportional of the y of t. Using the information that we have, we would say that it is equal to 3 over 2 ln of 2, a copy of the formula, which means 50 and 2 to the power 3 over 2 times 4.5, and we would use calculator, and we would end up 5596 bacteria per hour. And the last part, when will the population reach 50,000? It means that y of t is 50,000 somewhere. And using the formula, we would have 50 times 2 to the power 1.5 times t, as we found in section B. So we would divide both sides by 50 to isolate the part that has the variable or the unknown. So it will be 10, no, it will be 1000 equals 2 power 1.5 t. And when the unknown is the power, we are going to use ln. So ln of 1000 is equal to 1.5 ln of t. No, it will be the power, which is 1.5 t, and ln of the base. Now t in here will be ln of 1000 divided by 1.5 ln of 2, and using calculator, it will be approximately 6.64 hours. Okay, let's move on to the next part, which is finding derivative and simplify if possible. For the first part, it is a chain rule because we have x multiplied by ln of x. Excuse me, it's a product rule. So left part is y prime or dy dt. Dy dx, because x is in terms of y, equals Copy the first one, derivative of the second one, plus copy the second one, derivative of the first one, minus, we know that derivative of negative x squared is 2x. So dy dt dx will be x multiplied by, we know that derivative of ln of x is 1 over x plus ln of x, and we know derivative of x with respect to x is 1 minus 2x. Altogether, after simplification, it will be 1 plus ln of x minus 2x. Number 6. Is about finding derivative of ln of cosine squared of x. So dy dx, the overall function here is ln. So it will be 1 over whatever you have inside the parentheses, which is cosine squared of x, times the derivative of that. So d dx of cosine squared of x. Now, we know that, let's rewrite all these here. We know that derivative of cosine squared is basically power function because the overall function is a power function. So we would write the exponent, we would write the function itself with power 1 less, which is 1 here, and derivative of the inside without the power, which is cosine of x. So it will be dy dx equals 1 over, we have 2 for the top, and cosine and the power will be gone, so I would rewrite it as 2 over cosine of x. And the derivative of cosine, which is negative sine. And we know that sine over cosine is tan. So we would get negative 2 tan x. Next one is number 7. Number 7 is about a quotient. We know how to find the derivative of a quotient. So we would write it as f prime of x equals derivative of the top, which is 1 over x minus 0 multiplied by denominator ln x plus 3 minus derivative of denominator, which is 1 over x plus 0 times numerator, which is ln of x minus 1. All over denominator ln x plus 3 to the power 2. So we can simplify the numerator as we can factor out 1 over x, and it will be ln of x plus 3 minus ln of x minus negative 1, which is plus 1. These will be cancelled all over ln of x plus 3. squared. And 3 plus 1 is 4, so altogether 4 over x times ln of x plus 3 power 2. Number 8 is product rule. So f prime of y equals, copy the first one, derivative of the second one. But in here, it is dy d of whatever we are going to take derivative, dy. So ln of e to the y minus 1 plus copy the second one, which is ln of e to the y minus 1 multiplied by derivative of the first one. So it will be y multiplied by, this one is ln of e to the y. So it will be 1 over, this is a chain rule, ln of e to the y minus 1 times derivative of the inside, which is e to the y, plus ln of e to the y minus 1, and derivative of y is just 1. And you cannot simplify anymore, just rewriting. Okay, next one is number 9 here. For number 9, this is basically a power function because we have something to the power 3. So using the power function, it will be the power, the function, ln of e to negative x minus 1, the power 1 less, which is 2, times the derivative of the function or the inside, which is ln of e to the x, negative x, minus 1. So y prime will be 3 times ln of e to minus x minus 1 power 2 times derivative of this one is derivative of a ln. So 1 over e to negative x times derivative of negative x because it's a chain rule. And we know that derivative of negative 1 is 0. So altogether, it will be negative 3 times ln of e to the x, e to negative x, minus 1 power 2 over e to negative x. Number 10 is a quotient function. So y prime will be derivative of the top, which is 1 over x, times x squared minus 1 minus derivative of the denominator, which is 2x times ln of x all over x squared minus 1 squared. So we can simplify, we can multiply 1 over x into the next parentheses. We would get x minus 1 over x minus 2x ln of x all over x squared minus 1 squared. Okay, let's move on to the next one, number 11. Number 11 is about finding the equation of the tangent line. Whenever we want to find the equation of a line, we need slope and we need a point. So the curve here is x squared ln of x. So y is x squared ln of x and y prime will be found out using product rule. So copy the first one, derivative of the second one, which is 1 over x. Copy the second one, ln of x, times derivative of the first one, which is 2 times x. After simplifying, we would have x plus 2x ln of x. And the point is x equals 1. So when you plug in 1, you would get 1 plus 2 times 0 equals 1. This is the slope, and using the point that we have here, the tangent line equation will be y minus y sub 0, which is 0 here, equals m, the slope, which is 1 times x minus 1. And after simplification, we would have y equals x minus 1 as the equation of the tangent line. Next one. Use logarithmic functions to find the derivative of the following function. So this one is a function to the power of a function. As we talked in the lecture, we would take ln of both sides. So ln of y equals ln of x to the power sine of x. And we can bring the power down. So we would write sine of x times ln of x. Now we're going to take derivative both sides. Left side is y squared over y equals The right side is a product rule. So copy the first one. Derivative of the second one, which is 1 over x, plus copy the second one, which is ln of x, and derivative of the first one, which is cosine of x. Now, since we are going to find y prime, we would multiply both sides by y. And we know that y in this question is x to the power sine of x. So we would multiply both sides by x to the power sine of x. And we would write whatever we have here. For number 13 is when we want to find ln, we are going to take ln of both sides. So ln of y equals, using the formulas that says whenever you have expressions that are multiplied together, you can write ln of the first one plus ln of the second one plus ln of the third one. Now, taking derivative of ln is much easier. So we would write it as y prime over y. And for ln of square root of x, since we can rewrite it as ln of x to the power 1 over 2 and bring the power down, so we can take derivative of this one as 1 over 2 times 1 over x. For the next part, since ln and e can cancel each other, we are going to be left by x squared. And we know that the derivative of x squared is 2 times x. For the third part, we are going to use the derivative, which is 2x, over itself, which is x squared plus 1. Now, for finding y prime, we are going to multiply the whole equation here by y, which is square root of x times e to the power x squared times x squared plus 1 times this whole thing here. Number 14 is finding the derivative of the function y equals tan inverse. We talked about tan inverse, and the derivative of that is y prime equals 1 over 1 plus whatever we have to the power 2. If it is x, it would be 1 over 1 plus x squared. But in here, we don't have just x. We would write 1 over 1 plus x squared as we have here to the power 2 using the formula. Times the derivative of the inside, which is x squared, so the derivative is 2 times x. Two times x. So altogether, we would have 2 times x all over 1 plus x to the fourth. And the last one, find limit of tan inverse of ln of x when x is approaching to 0, but from the right side. So we can set the inside as t. We can set t equals ln of x. And we're going to find as x approaching 0 from the right side, what happens to t when x is approaching to 0 from the right side? It will be t approaching negative infinity. You can find it using the graph. Just imagine what tangent inverses graph is. And when x is approaching to 0 to the right side, then t is approaching to negative infinity. Now, limit will be limit of tan inverse instead of ln of x, we would write t when t is approaching to negative infinity. So using the graph, when t is approaching to negative infinity, tangent inverse will be approaching negative pi over 2. Okay, for this one, I think I said wrong. It is not about tangent here. Okay, when x is approaching to 0 to the power t, sorry for that. When x is approaching to 0 right side, it means that ln of x when x is approaching to 0 from the right side. So for the graph of ln, which is something like this, when x is approaching to 0 from the right side, it's somewhere here, very close to 0. You see that the graph, which is ln, is going down. It means t in here, because we set t as ln of x, is going to be negative infinity. And then for the limit, we're going to use the graph of tan inverse of t, which was between two lines, negative pi over 2 and pi over 2. and the graph was something like this. When t is approaching to negative infinity, the graph is going to be close this line, which is negative pi over 2. Okay, that's it for the worksheet.